All right, we are ready to do our first hypothesis test called a one proportion z-test. So we have an example here where we have a 1996 report, wow, that's a long time ago, that claimed at least 90% of all American homes have at least one smoke detector in their house. So think about your house, where you live. Can you imagine in the rooms, all right, smoke detectors? Right. I mean, you don't have to say it. It's okay. I'm just imagining where they are, right? Right there. Okay. So you should, if you're curious and you don't know, go find out tonight. All right. And if you have zero, have a conversation with the adults in the house. Okay? Because that's no good. Okay, that's scary. I don't want you guys to not be here tomorrow. Now, it says in Houston, a city's fire department, Houston, has been running a public safety campaign, I'm sure you've heard it on the radio, about smoke detectors consisting of posters, billboards, and ads on the radio and TV. And in the newspaper. Who reads that? The city wonders, exactly, if this effort has raised local levels above 90%. So above 90%, the national rate. So it says building inspectors go to 400 randomly selected homes and find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? Here we go. Let's define the parameter. Yeah, if you need to like stretch out your hand or like your wrist. Here we go. Let P represent the proportion of all Houston homes that have at least one smoke detector. Boom. We defined the parameter P. All right? Now, I don't know what this is, guys. I'm not going to go into every house in Houston and count smoke detectors. I don't have the time, the money, I don't care. Okay? So, but I'm saying that I'm going to make conclusions about this based on the sample that the building inspectors did. Okay? So that's why we have to define the parameter first, because that's what we're going to write a conclusion about. Okay? Everybody good? Step one, the null hypothesis. We think right now that the best idea for the proportion of all Houston homes that have at least one smoke detector is the national rate of 90%, 0.9. Now, the fire department has been spending a lot of money and time trying to get this rate to do what? Increase. So the alternative is going to be P is greater than 0.9. That's what we're hoping to prove. We're hoping to have enough evidence based on these building inspectors' numbers that say, you know what? In Houston, the rate's higher than 90%. That's what we're trying to prove. All right? So one thing I always tell students is whatever you're trying to prove needs to go in the alternative hypothesis, H sub A. Always whatever you're trying to prove goes in H sub A. Okay? Okay. The next slide. Oh, baby. Here we go. Woo! Step two, the model. Okay? Let's make our first assumption. You know it. All right, Jarvis, hit me with it.
The number of smoke, if one person has a smoke detector in the house, it doesn't affect it.
Perfect. So one house's smoke detectors doesn't affect other homes. What do you guys think? You think that's true?
Yeah.
Why not, Jarvis?
The
they're all built at the same time.
Interesting.
Because everyone doesn't build their house and pieces are already installed.
Okay. I worry about older neighborhoods. Right? Houston's fairly old, so I worry about like whatever the new code is, right, when they're building these homes. So I worry that if they're sampling these 400 homes in only older neighborhoods, right, or in one pocket of the city, what if they tell you they only go to southeast Houston or northwest Houston, right? That would be an issue. But if it's going everywhere, I'm not that worried about it. Okay? So good ideas. Let's check some conditions to make us feel better. The randomization condition. Does it say anywhere in the problem that it's a random sample? Right? Awesome. So it's a random sample of 400 homes. Okay? And you guys remember the statement you're going to write if it doesn't mention randomness, correct?
Yes.
400 homes is a good representation of all the homes in Houston. Okay? The 10% condition. So we're going to take our sample size of 400 times 10 is 4,000. Are there more than 4,000 homes in the greater Houston area? Absolutely, okay? So our sample size of 400 is not too large. Okay, let's go to the next column. Let's make our other assumption. The sample size assumption. Okay, who's got that one? Let's go with Edgar. Do you remember this assumption? You don't? Sad. You're going to need to know that for the quiz. Okay. Bianca, do you know this one? That was not meant to be like that. I don't understand.
400 is the largest.
Perfect. 400 homes is a large enough sample. Again, don't worry about the words being exact, right? Exactly the same as mine. It's okay if they differ. All right, just the main idea I'm looking for here. All right, and what's the condition we check with proportions? Success, failure. Now, I'm going to show you something that's going to be a little funky. Okay? So success, failure condition is n times p, n times p, and n times q. Now, before, when we did our confidence intervals, I just told you if they give you the number of successes, go with it, right? And in this case, they gave you 376. But we're not going to use that. Because right now, what do I think is the best idea for the rate of homes that have at least one smoke detector? 90%. So I actually have to use 400 times 0.9. And that seems a little bit weird because we hadn't done that before. And then 400 times 0.1. So it's 360, I heard, and 40. And those numbers need to be 10 or more. You got it, Bianca. And both are greater than 10. Okay. Almost there. Almost. I got one more sentence. Bianca knows. The conditions have been satisfied. You guys are quicker than I am. So I will use, you got it, the normal model to run a 1 proportion. Oh my gosh, Travis. I'm not there yet. Proportion z-test. All right, good job, guys. We haven't even started the math yet. Good work. It's been 10 minutes for those of you keeping track. Gosh, I love this stuff. It's so good. No, I mean, you're going to get really good at this. Go fast, right? It takes me like 7. It's been longer than that, hasn't it? It's been 10 minutes. All right, checking the time. All right, let's go to the mechanics. Here we go. Let's write down the stuff they gave us in the problem. So they gave us the sample size of 400. How many successes? So how many homes had at least one smoke detector? 376. So now, Jarvis, I'm talking about the actual sample, right? The sample. The building inspectors did the sample for us. So for p hat, right, from our sample proportion is 376 over 400, which is 0.94. Yes. Okay, let's write down the formula. Remember, this is going to be given to you. All right? Z equals, and I'm not going to write P sub 0, Leslie. I'm going to write P, but you can write P sub 0 if you'd like. P hat minus P over the standard deviation of P. Okay? Now, the standard deviation of P is the square root of P times Q over N. I'm hoping you're not really that concerned because this is stuff we've already used. Okay. So z-score, I'm going to slow it down because I know I'm going fast. Slow it down. So the z-score is calculated first with the sample proportion. So go find your sample proportion, which is 0.94, minus our population proportion. And whenever you're doing this, you can go right back to the null hypothesis. Go right back to the null hypothesis. What did we say P was equal to? 0.9. 0.94 is the actual homes that the inspectors visited. They visited 400 Houston homes, and 376 had one or more smoke detectors. So if you divide that, you get a proportion of 0.94. So that's called a sample proportion. And we're comparing that, Saul, to our population proportion. We think right now, Saul, that the rate of homes in Houston that have one or more smoke detectors is 90%. We want to see, is this enough evidence to say, you know what, it's not. It's more than that. That's what we're trying to prove right now. All right, divided by the square root of 0.9 times 0.1 over 400. Now, one thing I learned when I was in high school doing this for the first time, my junior year, my teacher said, always visually check that the 0.9, your P, is also in the denominator in that numerator, right? Those should match every time. And I should only see 0.94 one time. Okay? So a lot of students, not a lot, some students will mess this up by putting 0.94, 0.06 down here, which is wrong. Don't do that. You're basically saying right now that 0.9 is it. That's what we think it is. We think it's 90%. So we're comparing everything to the 0.9. Okay? So now take out your calculator. Oh, man, you've already done it, Leslie. Do you need one? This student had two, I guess. All right. So we have 0.94 minus 0.9. We know that one. Divided by you got the sleepy monster? What does that mean? Okay. So I got 2.6 repeating. Everybody get that? 2.6 repeating? Okay. So once you get this, you're going to draw a curve. And I think there should be a blank slide below. Let's draw a curve there. Okay? So we're going to draw a curve below. Oh, I don't think this one's going to be as good. It's okay. Not great. I mean, half. I did half. You do you. Okay. So 2.6. What did I do?
Oh, that's why.
You good? You're good. If you can stay on the slide, stay on the slide. I'm just telling you, I gave myself another slide because you know I read big. Okay, so 2.6 repeating. And which way am I shading? Because we're talking about looking at the alternative. Remember the sign that we used? The sign was greater than 0.9. So greater is to the right. Okay, so now if you have your cell phone, and you don't have to take it out today, you'll get a Chromebook tomorrow if you want, but if you want to take out your cell phone and go to the email I sent you on, I think it was the 9th. Come on. Come on. Yes, the 9th. Z-score calculator for Desmos. All right, and again, you'll have this in a Chromebook if you want it. Well, it may not be using it if it doesn't let it. Sad, Charlize. Sad. Oh, wait, happy? Happy! All right. So I'm going to go to my normal distribution, right? This is the normal model. What's my lower number? 2.6 repeating. So I'm going to go to that min, and I'm going to type in that min 2.6 repeating. And you can write 2.67, 2.6667, however many you want. Don't get crazy here. Just a couple and then throw in a 7. Okay? What's my maximum going to be? Infinity. So I'm going to put a bunch of 9s. And really, if you put 99, it'll be basically the same. Okay? So when I do that, all right, I know it's hard to see, but it is up here on the screen. All right, it is shaded there. You can barely see it. So how much area is that under the curve? Not much. 0.004. Okay, so I'm going to write that down. And you know what that's called? That's called the p-value. Okay, and I told you guys during the lecture portion that if you don't include that, you can't get full credit. So I have to see the test statistic, that's the z-score, and the p-value. Those two things is what I'm grading for with the work. Okay? Now, let me do my best. And again, this is the first time. Leslie, I'm sorry.
Can you go back and show where the...
Absolutely. Unlike this webpage? Yeah, so it's this area under the curve. That area under the curve, remember the curve is 100%, right? Little tiny portion is 0.004 or 0.4% of the curve. So not a lot at all. Now, I want to do my best to try to explain to you what this p-value means, okay? So open your ears to this, okay? If I assume, before going into these homes and looking up for the smoke detectors, if I assume that 90% of all the homes in Houston have one or more smoke detectors, the likelihood that I would go into 400 of these homes and find 376 or more that had one or more smoke detectors is 0.4%. Okay? Now, I know that that means that's very unlikely to happen. Okay? Talking about 4 out of 1,000 times will that happen. And if you don't know anything about odds, you should know that 4 out of 1,000 tries is not likely. Okay? So what we're going to conclude here is that, in fact, it's not just one of those, whoa, that's really unlikely to happen, and you got one. What's more likely is that it's not 90%. What's the rate of the homes in Houston that have one or more smoke detector? It's actually above 90%. So here we go. Conclusion time.
Wow.
Don't worry, if you just still didn't, we got a lot more to do. Me? I hope so, right? I'm the teacher, so I should be. Okay. With my p-value being so small, I am going to reject the null hypothesis in favor of the alternative. Now, I like doing this statement first because it tells you what I'm doing. I'm rejecting the null in favor of the alternative. But you should notice, as you finish writing the statement, that that statement has nothing to do with smoke detectors. All right, do you see how it's lacking context? All right, this is literally has nothing to do with the problem right now because I said nothing about homes or smoke detectors. So I have another statement. I add another one on. Ready? there is enough evidence to conclude that the proportion of Houston homes that has one or more smoke detectors is above 90%. Whew. Okay. Okay, well, yes and no, Jarvis. The 100%, I'm not lying to you, we're done. Okay, but we're not. That makes sense. But if this is a test or a quiz, you're finished. Okay? But I want to go further. Okay? Well, if you read our conclusion, right? If you read our conclusion, we said that, you know what? It's not 90 anymore. We think it's what? Above 90. But my question is, if you're telling me it's above 90, then what is it? Enter a confidence interval. Yes. Together. They're together. I mean, they're two different sentences, but they're the conclusion.
Is this a Shakespeare play?
I don't know if that's a compliment or no.
That just means he doesn't understand you.
No, that means you're entering a new meaning.
Okay. It's all good. I am going to run a 90% confidence interval. And I'll explain to you tomorrow why I chose that level of confidence, because it's not random. Okay? There is a reason of why I chose that level of confidence. But for our purposes today, I just want you to see what happens when we run this 90% confidence Z interval. Okay? Now, if you remember, I'm not going to do the assumptions and conditions because we already checked those. But if you remember from last week, the formula is p hat plus or minus z star times the standard error of p hat. And the formula for standard error of p hat is the square root of p hat times q hat over n. And again, these formulas will be given to you. Okay, so now let's think about this. Okay, what is the p hat I'm using in this problem? 0.94. 0.94, right? That's my p hat. Let me go back up here. That's my p hat. 0.94. Okay, so I'm going to put 0.94 for p hat. What your brain was doing, your math was z star, I think. Right? What is the z star for 90% confidence? And Edgar and Bianca, you have this memorized for the quiz. 1.645. Very good. Times. Missed the 5. There you go. Times the standard error of p hat. Now this is important, and it took me a long time when I was in high school to really understand this. Okay? My teacher was like, "You gotta learn this." I'm like, I'll try it. When we've already booted out what number? What number do we not care about anymore? 0.9, 90%. We know it's wrong. Okay? So when you write these, when I was in high school, I was like, oh, cool, I'm going to do what I did before, right? 0.9, 0.1 over 400. But we're saying that's wrong. So why would we use a number that's wrong? So I'm going to use 0.94 times 0.06 over 400. I'm just using the same number from here, Jarvis. Because it doesn't matter that it's bigger than 90, it's because I think the null hypothesis is wrong. So I'm not using anything from the null hypothesis anymore. I know. Okay? So if you use your calculator.
Like, can't you just use the 376?
That's what I was going to say. Why?
It is. 376 over 400 is 0.94. I'm using the same number. Yeah, we're on the same page. Yeah. I think we're in different books. We're on the same page. Okay. Like Othello and Hamlet. Right?
Oh, those tragedies though.
I'm out of my element. I don't know what that is. I mean, I've read both of those, but I don't know. Okay. So we have the square root of 0.94 times 0.06 over 400 times my z star of 1.645. So my margin of error is 0.020, looks like. If I round, 0.020. Okay? So if I add and subtract, I will get 0.920 and 0.960. So here, my statement is I am 90% confident that the proportion, you're good, of Houston homes that have at least one smoke detector is between 92% and 96%. Oh my gosh. Man, that was fun. Okay, we're not done yet. That was good. Now, once you finish writing, this is what I need your brain to get by doing this confidence interval. Okay? So I know you guys are done with me. I totally get it. And especially the worst timing, right? Tuesday, last period of the day. Totally get it. Awful timing. Don't blame me. Blame Power School. Now, I want you to take a moment. Everyone take a moment. I know you're still writing, but take a moment and look up here. All right? Everyone look at the interval. All right? My low number is 0.92. Wait for you. I thought you already got it. Wait, is below. My low number is 0.92. My high number is 0.96. Do I know what the number is? I don't. I'm 90% confident that the proportion for all homes in Houston that have one or more smoke detectors is somewhere between 92 and 96%. But I don't know what it is. But no. What do you notice is not in this interval? 90%. So that's why we rejected 90%.
We have put it in